All right, everybody, section 1.10, we're going to be focusing in today on when we have rational functions in factored form. And the exponents on those factors, those multiplicities, are something other than 1. So first, let's talk about this. It says that a rational function cannot have a vertical asymptote, whole or 0, at the same x-coordinate as another one of these things. All right, in other words, only one of those 3 is allowed at each x-coordinate. And so you guys will see what I mean in a second here. Now, I want you guys on your paper, you're going to write just VA. It should make it really large. Okay. And then below that, normal size, you're going to write the word whole. And then at the bottom, tiny, you're going to write 0. So here's what this tells us. If in an equation, it looks like there's a vertical asymptote and a whole at the same point, it's just going to be a vertical asymptote, not a whole. All right. Or if it looks like the graph has both a whole and a 0 at the same point, it's actually just going to have a whole, not a 0. All right, so let's see what that looks like in a question. So we're gonna do mostly just one really large problem here, and then at the end just a little reminder. But so let's talk through this. So I'm going to go through and see if anything cancels first, and whether it completely cancels or partially cancels. All right, so the only thing that's going to completely cancel are those x minus 4s because they have the same multiplicity here. All right, so the x minus 4s cancel. So remember, anything that cancels automatically becomes a whole. All right, so we're going to set x minus 4 equal to 0, and that's going to give us x equals 4. Now, normally we're going to have to get the y coordinate of the whole. We're going to hold off on this problem just because of how much is here. But the x coordinate of the whole is x equals 4 because those completely cancel. Next, I'm going to look for what doesn't cancel at all. All right, so we've got an x plus 2 on the top. There's no x plus 2s down here. So if we set something in the numerator equal to 0, that gives us the x value of the 0. All right, and so we're going to set x plus 2 equal to 0. That's going to give us x equals -2. And then in the denominator, this x plus 4 does not cancel with anything. There's no x plus 4s up here. So if we set the denominator equal to 0, that gives us the vertical asymptote at x equals -4. Now, I started with these factors because this is nothing new. If something completely cancels, it's a whole. Okay, if something is in the numerator and doesn't cancel at all, then it's a 0. And if something's in the denominator and doesn't cancel, it's a vertical asymptote. What's new with this lesson is when we have factors with different multiplicities that will partially cancel. All right, here's what I mean by that. This x minus 3 is to the first. This one is to the second. So this x minus 3 is going to completely cancel down here. But up here, it's like there's x minus 3. There's 2 of them. Only one of them cancels from that one. So this becomes now just to the first. Okay, so it canceled, but there's part of it left over in the numerator. And so here's the confusing part, right? When something cancels, typically we're just going to say, oh, it's a whole. But now we have to consider, based on this hierarchy right here, which one is it going to be? Well, it's not in the denominator. Okay, the x minus 3, it's gone. So it can't be a vertical asymptote. It canceled. Again, that would typically be a whole. And it's left in the numerator. That would typically be a 0. All right, so we're looking at, is it a whole or is it a 0? Well, if it's between these two, that's our answer right there. Okay, so x minus 3 is going to be a whole. So x equals 3 is the x coordinate. Yeah, x equals 3. Then the x plus 1s. All right, so this x plus 1 is to the first. This one's to the third. So this one up here is gone. It's like there's 3 of these, 2 of them are left. So now this is to the second. All right, so again, something partially canceled. Typically, again, that would be a whole. But because it's left over in the bottom, we're looking at, is it a vertical asymptote or a whole? It can't be both at the same x coordinate. So we're going to set x plus 1 equal to 0. That's going to give us -1. And because it's in the bottom, right, and that's how we get the vertical asymptotes. When something looks like it's a vertical asymptote and a whole, right? Where it's just a vertical asymptote. Okay, so at x equals -1, there's also a vertical asymptote. All right, we're going to do a ton of practice with this. So it'll get a little bit easier as we go. But quick reminder, if the multiplicities are 1, okay, then today's lesson doesn't apply. So for example, if it's just like y equals x plus 3 times x minus 2 over x minus 2 times x plus 1, right? All these exponents are 1, and this is more what we did yesterday, or whatever the last video was, about vertical asymptotes, holes, and zeros. So you would just cancel those, right? That's going to give you the coordinate for the hole. The numerator gives us, like after we get rid of that, the numerator gives us the zeros, the denominator gives us the vertical asymptotes. All right, guys, that's it. Stay flawless.